Welcome, everyone. I hope you're having a great reInvent. If you're here, it's because you use AWS. And if you use AWS, it's almost guaranteed that at some point, sooner or later, you'll be storing your data on Amazon's Simple Storage service. S3 is a foundational service providing scalable, flexible, and durable object storage in the cloud. And as soon as you start putting data in the cloud, your top priority becomes securing that data, making sure that the data is accessible to the entities that need it and no one else. We at AWS deeply understand having security as a top priority because we think about it that way too. I'm Meg, later you'll hear from Raymond. We both work on S3, and this is what we think about all day. Because S3 is so ubiquitous within AWS, it's worth acknowledging that there are many different types of data that you might be putting in S3. They're different and they have different security objectives. S3's extreme scalability, availability, and durability make it a great place for your data lake. By storing your business's data lake in S3, you'll unlock so many different analytics, machine learning, and other workloads, both from our AWS service offerings, our partner offerings, and your own applications that give you so many more sophisticated ways to derive data from that derive value from that data. So that's one way you're probably using S3. You're also probably storing your outputs in S3 at the end of the day. For example, it might be where your log data ends up. S3, as a highly available object storage service, is also a highly convenient place to store your configuration data, the bits and pieces of data that make your applications work. And, in fact, this was one of S3's flagship use cases. It's a great place to store content for your users. This includes websites and media, content, anything that you want your customers to see. And who's using this data? Certainly human users, for example, consumers of the content that you're hosting, or data scientists interacting with your data lake. And that little red worker hat that you'll see us use throughout this presentation to represent AWS's Identity and Access Management, or IAM, authenticated identities, your applications and workloads that produce and consume data in AWS, those will be interacting with your data as well. And your whole job here is to protect this data, no matter what it is, and no matter what the desired use cases are. And that's what this talk is all about. And in fact, we know that when you're securing data in the cloud, there's a lot of chatter and advice out there, so much so that it can seem complicated. It's not. In preparing for this talk, we thought about the tactics that our customers use to successfully secure data in S3, and we boiled it down to 5 best practices. And this is a deep dive talk. So while the advice that we're going to give you is going to be straightforward to implement, we're also going to explain a bit of the why and the how it works for those of you who are interested. We're first going to talk about S3's block public access setting. This is the most important of our best practices because with one step, you prevent data in your bucket from being accidentally made publicly available. We're then going to talk about data encryption in S3 and picking the encryption option that best works for your business and use case, and a bit about how it actually works under the hood for those of you who are interested. We're going to talk about IAM policies because all services in AWS are secured by means of IAM policies, and S3 is no exception. We're going to talk a little bit about what we think the best S3-related IAM policies look like. We're going to give you some pointers on simplifying managing your objects. And finally, we're going to talk about some of S3's monitoring tools that allow you to understand access to your account. So let's get right into these best practices, starting with our first and most important one, block public access. When you're getting ready to use S3 in your account, what's the first thing that you do? Well, you create a bucket. And like all other resources in AWS, which means things that you own, S3 buckets are owned by the account from which it was created. And like everything else in AWS, at the moment you create an S3 bucket, it is impossible for any entity from outside that AWS account to access your bucket. Yes, there are configurations by which the bucket can be shared to entities outside the account, and in a large enterprise environment, you'll be doing that a lot. But until you take deliberate action to configure your bucket that way, it is private. And maybe we should explain what entities within the account means exactly. As I mentioned before, AWS's identity system is identity and access management. The identities in IAM are called principals, and you will see that word again later this talk, but they represent users. IAM, in fact, has users, but most modern use cases involve the IAM role, which is an identity associated with temporary signing credentials. IAM roles and users use their credentials to sign requests to the AWS API, and this includes the S3 API, and these are authenticated requests. Actually, IAM users and roles are themselves AWS resources. They belong to an account. Here I'm showing you some IAM roles that belong to the same account as the bucket I just created. So they're in the same account, and the bucket's private by default. So can they all access the bucket? Actually, no. IAM principals have policies attached to them that say what they can do. So they might have access if they have an IAM policy saying that they have access, and we'll see how to do that later. But you know who definitely does not have access? An identity, either an anonymous user or an IAM principal belonging to some other account outside this bucket's account. And no matter what policy in their account says that they can do, unless the bucket was configured to grant them access, they definitely do not have access. It is, of course, possible and very common to configure your bucket for read, write, or both outside of the account. And as I said before, in a large enterprise environment, you're definitely going to do that a lot. But even if you have a ton of those cross-account data sharing scenarios in your environment, it's pretty unlikely that any of these scenarios intend to make the bucket fully publicly accessible. And so S3 block public access is a simple feature by which you declare that the contents of this S3 bucket are under no circumstances to be made publicly available. What that means, very technically, is that unless you have a specific configuration on the bucket granting access to a specific outside entity, outside entities will be denied access. Does that mean that you can no longer share data outside of your account? No. This is a particularly powerful feature because it's not a hammer locking data inside of your bucket, but rather it's targeted at preventing accidental exposure. And in fact, to make this feature even simpler, you can and should set it account-wide. When you do this, it means that all of your S3 buckets, existing and future, will be covered this way. It's a set and forget with no configuration required after the configuration is turned on. Now, that's all you really needed to know. Go home, check if your accounts have block public access on, and if they don't, and your data is not public, which it almost certainly is not, then turn it on. But as a builder, you're gonna go enable it, and you're gonna see that there are 4 subsettings under there. All you really need to know is that you want all of them on, but this is a deep dive session, so let's quickly break it down. There's really 2 sets of 2 settings. The first and third ones I'm showing here, block public access granted through new access control lists and block public access granted through new policies, concern any new configuration changes that somebody in your account might attempt to make to your bucket after you've enabled S3 block public access. Block public access is a simple feature for our customers, but it's powered by our automated reasoning, which applies mathematical techniques to prove whether a proposed new policy is public or not. All that is a fancy way of saying that if somebody tries to introduce a bucket policy or an access control list, which is an older way of sharing data within S3, that would have the effect of turning your data public, they'll just get an access denied and they won't get to make that update. The second and fourth ones, block public access granted through any access control list and block public access granted through any policies, both concern what happens to an S3 bucket that had pre-existing policy or access control list that made it public before you enabled block public access. It basically means that these configurations will no longer have the effect of making your data public. Any access control list that granted a public read or write access will just be ignored. If our automated reasoning determines that a policy was public, it will limit access back down to within account only. So that's precisely what these do, but again, your job is to just turn them all on. All right, so let's talk about these different scenarios for data in your bucket. Show of hands, who thinks that block public access is appropriate for your data lake buckets? Awesome, and thank you for those of you who are playing my little game. Absolutely, that's not public data. You have specific workloads and people who need to access it. What about configuration data? Awesome. That's also not public. Your applications will need it, but those are IAM roles in your accounts. Log data? Also not public. Perhaps this was too easy. What about static website content? You actually do want your customers seeing your website. Who thinks that this is a good fit for block public access? Excellent, yes. The best way to run a website in AWS in the modern era is to use our content delivery network, CloudFront. And in this case, CloudFront, which provides awesome benefits for your customers like edge caching and low latency, is a specific AWS service. And you configure your S3 bucket as an origin for CloudFront, which again is sharing it to a specific service. So this is not actually public data. All right, what about public data sets that you wish to make directly available from S3? Anybody think this is a good use case? Awesome, those of you who didn't raise your hands. No, it's not, but this is a rare use case, and if you truly, truly, truly have a need to serve content out of S3 directly to the public without a content delivery network in front of it, what we recommend you do is you take those buckets and you sequester them in their own account and enable block public access on every other account in your environment. All right, let's move on to our second best practice, encryption. When we talk about encryption in S3, what are we actually talking about? Well, S3 supports a few types of encryption. You can encrypt your data client side with the AWS Encryption SDK. We support encryption in transit. And we have 3 options for encrypting your data server side for encryption at rest. This talk is going to be focused on these at rest options. And we're going to start by taking a look at the most commonly used encryption modes through the lens of your ability to manage key policies, additional visibility that you might get into AWS CloudTrail, your ability to control the key rotation, and their impact on data shareability. The most common mode that we see our customers use is SSE S3. Now, customers are making their encryption decisions based on their business, security, and compliance requirements, excuse me. And SSE S3 is a great option for those customers who just want to be sure that their data is encrypted. This is a free option, and your data will be encrypted. You do not manage key policies. You don't get any additional visibility in AWS CloudTrail. S3 handles the root key rotation, and there's no impact on data shareability. Customers who have more advanced security and compliance requirements often like to control the keys themselves. In this case, we recommend that they use AWS's Key Management Service, abbreviated here KMS. S3 will use keys controlled by the customer to encrypt the data server side. So in this case, SSE KMS with a customer managed key, the customer manages the key policies. So we're going to talk about policies later, but these key policies say who can do what with these customer managed keys. You get additional visibility into AWS CloudTrail for all key usage. You handle the key rotation frequency according to your business's requirements, and there's no impact on data shareability provided your key has the right policies in place to promote the shareability that you need. Some customers like the idea of KMS, but they don't want to manage their own keys. We do have an option for these customers, and it's called an AWS Managed Key. In this case, the customer does not manage the key policies. They do get that additional CloudTrail visibility into key usage. They don't handle the key rotation, but importantly, they can also not share data outside of their account because they cannot write key policies that support that. And so if there is any chance that you might in the future want to share your data outside the account, we really recommend that you choose one of these other 2 options. All right, so you've selected the mode that works right for your business, and you want to make sure that we're starting to encrypt new objects. So you can specify this at a per object level using headers. This first example will encrypt your object with SSE S3. You're just specifying the mode here because remember, you don't control the keys for SSE S3. If you've chosen SSE KMS, you need to specify 2 headers, the mode, KMS, and the key that you want to use. But you might be saying, man, this is a lot of work. I don't want to change my application. In this case, you can enable a bucket level default setting. This is a one-time setup, and it automatically encrypts all new objects. Again, here you choose SSE S3, where S3 is handling the keys, or SSE KMS, where you, the customer, are handling the keys. You pick your key, and remember, if you do choose this AWS managed key, you're not going to be able to share that data outside of your account. And if you've chosen bucket keys, if you've chosen KMS, you should enable bucket keys. We're going to talk a little bit more about what this means exactly, but this is designed to save you money. All right, we're going to take another quiz. All right, if the put has no headers that specify encryption, and this bucket has SSES3 default enable, raise your hand if you think that the bucket's going to have, or that the object is going to have no encryption, or this object's going to be SSES3 encrypted. All right, thanks for playing SSES3. This next example, the put specifies KMS, the bucket has no default encryption. Raise your hand if you think it'll be KMS encrypted. And raise your hand if you think it won't be encrypted. All right, here we get SSE KMS. Now for the complicated one, we have a put that says, I want this object to be SSES3 encrypted, and we have a bucket level default that says, no, we want it to be KMS encrypted. Raise your hand if you think this object will be SSES3 encrypted, and raise your hand if you think that the object will be KMS encrypted. Yeah, so we can see a split here. It's actually SSES3. And let's talk for a minute about the mental model here. When S3 sees a conflict, so both the put and the bucket are specifying an encryption mode, and they're conflicting, S3 is going to respect the more granular one, so what the put is saying. This is also important because if they both specify KMS, but they specify different keys, the key specified in the put is going to be the one that is used to put the object. Now, you might have very specific business requirements to use a specific mode or even a specific key, and so you're probably concerned with how you can prevent this scenario from happening. And the answer here is to use a policy, and again, we're going to talk a lot about policies later, but this is a simple example that denies puts that are not using KMS encryption. You can make this more fine-grained by adding a specific key if you have requirements to do that. All right, we're going to talk a little bit about how encryption works. There's some deep dive content. You certainly don't need to know it. All right, so how does an encrypt request work with KMS? A customer issues put requests, and either in the header or with that bucket level default setting, they're specifying that it should be put with KMS. S3 sends a request to AWS KMS and says, can the customer use this key? If KMS decides that the customer can use the key according to the policies that are in place, it sends back a plaintext data key. This is a unique key. S3 uses that to encrypt your object, and we store an encrypted version of that unique key alongside your object. And then we destroy the plaintext data key. Now on read, the customer is attempting to get an object, and S3 identifies that this object was KMS encrypted. We send the encrypted data key to KMS. KMS again evaluates the key policies and sends back that unique plaintext data key that S3 used to encrypt the object. S3 decrypts the object and sends it back to the customer. And again, destroys that plaintext data key. Now, I mentioned bucket keys earlier, and I said you should definitely turn it on, so let me explain what it is. Bucket Keys was launched in 2020, and it's designed to improve performance and reduce request costs for KMS by up to 99%. So let's understand how this happens. When you've enabled Bucket Keys on your bucket, the first KMS request looks very similar to what we just discussed. You're putting an object, you're specifying that it should be KMS encrypted with bucket keys. We send a request to KMS. KMS determines if you can even use this key, and if you can, sends back a bucket key. S3 uses that bucket key to derive a unique data key, just like we used a unique data key in the KMS example, encrypt your data, and we store an encrypted version of that bucket key alongside your object instead of the unique data key. The next time, and of course we destroy that plaintext data key, the next time a customer puts an object in this bucket, S3 identifies that we already have the bucket key. The bucket key is time limited within S3. S3 goes ahead and derives another unique plaintext data key, encrypts your object, and stores that bucket key alongside your object. You notice that there is no call to KMS. This is what improves performance and saves money because we're not paying for that request to KMS. Now let's look at how a decrypt works with bucket keys. Again, on a GET request where we've encrypted the object with KMS with bucket keys, S3 identifies that. S3 sends that encrypted bucket key to KMS if we don't already have it, and S3 sends the plaintext bucket key back. S3 uses that to rederive the unique object key that was used to encrypt the object and decrypts the object, sends it back to the customer, and destroys the plaintext data key. On the next request to the bucket by the same customer for an object that was encrypted with the same bucket key, S3 doesn't need to go to KMS. We go directly to that bucket key, which is time limited within S3, rederive the plaintext data key that was used to encrypt the object, decrypt the object, send it back to the customer, and destroy that plaintext data key. And so again, you can see we're saving money on the GET here as well. All right, now that we've talked about encrypted options in S3, a framework for deciding which one is right for your use case and how it works under the hood, let's talk about how you can audit the encryption status of objects in your environment. We recommend that you use S3 Storage Lens. S3 Storage Lens provides organization-wide visibility into storage usage, which you can use to improve cost efficiency, but also data protection. It has an interactive dashboard that's built into the S3 console, providing a central organization-wide view of S3 storage across all accounts and buckets. You can drill into detailed views of storage class, buckets, and prefixes. In addition to the dashboard, you can also use the metrics export option to send the data daily to any S3 bucket in your account. From there, it can be consumed into your local analytics environment. We do find that some customers prefer to see storage lens metrics alongside their other monitoring metrics from any other AWS services. To do this, you can enable the CloudWatch Publish option, which allows you to access them via the CloudWatch API and use native CloudWatch features like alarms. So let's think about how we can answer encryption questions with Lens. Well, one of the most important ones that we can answer is which buckets have unencrypted objects. You can quickly pinpoint these. Here, note that SSE objects is any SSE encryption mode. So this is both SSE S3 and KMS. But here we see a bucket that has 1.5 terabytes of unencrypted data, which is the entire bucket contents. And so we can assume that we likely need to address the bucket level default on this particular one. Storage Lens recently added metrics specifically for SSE KMS. You can now assess if the required buckets in your account have SSE KMS enabled, and also check the SSE request counts for KMS. And note here, when we say KMS, this is both SSE KMS with and without bucket keys. Relating these metrics together can actually allow you to identify discrepancies. So for example, I can see here that the bucket with the prefix game day has encrypted bytes and they're still receiving KMS requests, but the KMS enabled bucket count is 0. And so if it's important to my business that the data in this bucket be KMS encrypted, I should add a bucket level default setting to prevent any regressions in the future. That brings us to the end of our encryption talk, and we're now going to hear about our third best practice from Raymond.
Thank you. Good job. Thank you, Matt. Welcome, everyone. My name is Raymond, and I'm so excited to be here with you today. This is best practice number 3, and we will go over AWS Identity and Access Management Policies, or IAM policies. We launched the IAM service in 2011 to manage the authentication and authorization for all AWS services. So IAM policies sits in the center of security in AWS. It's important to learn how to read policies and learn how to write good policies because they are really useful cloud skill. Many people think that they are actually hard, but in fact, they are quite simple. So we have some experts here in the audience today. For those experts, some materials may look familiar, but we are going to start from the basics and go deeper from there. When you have data in Amazon S3 and have user using that data, you need a way to give them access. To do that, you have a few options. You can define an IAM policy, a bucket policy for your bucket, or access controllers for the bucket and each object in that bucket. In most use cases of S3, you want to use policies, whether it's IAM policy or bucket policy, because they are very easy to review and update. very scalable when you need different permissions. We'll come back to access control list later on. An IAM policy is an access policy that you attach to your IAM user or IAM role. A bucket policy is a similar access policy, but you attach to your S3 bucket. Both IAM policy and bucket policy use the JSON format, so you can easily relate one to the other. Let's go over IAM policy. So before we look into some examples, let's talk about how IAM policy worked. In IAM, you have principals. These are the identities in the IAM system. Your identities are going to perform some actions in terms of API requests to some AWS resources. Examples of AWS resources are going to be your S3 bucket or objects. So an IAM policy defines what actions this IAM user or IAM role can or cannot do. It has 3 elements: effect, action, and resource. For this IAM policy, the first element, the effect statement, tells us whether the policy is allowing or denying access. The second element, the action statement, tells us the action or API operations that it's being allowed or denied. In this example, the action is to read and write objects to Amazon S3. The third element, the resource statement, tells us what AWS resources the action applies to. So this is all you need for an IAM policy. This IAM policy effectively allows this particular IAM user to read and write objects to the bucket called reinvent sample bucket. And now, depending on the action, you need a different resource. For example, when we read and write objects, we use a wildcard behind a bucket name to define an object resource. But for the list bucket operation, because we are listing contents in a bucket, we need a bucket resource, so no wildcard. Here we have a nice QR code. It directs to the AWS documentation page that maps action to resource. It's very handy when you're working on your policy. You may wonder who gets to apply IAM policies. Well, if you are the administrator of your AWS account, you can define an IAM policy and attach it to any IAM user or IAM role within your account. You can further allow an IAM user to assume an IAM role. And with the role assumption, the IAM user inherits the permissions of that role. So role assumption becomes handy when you have multiple environments that require different permissions. Imagine that you have 3 environments: production, testing, and development. What you can do here is to define 3 different roles. Role 1 with just enough permission to deploy to production. Role 2 with just enough permission to deploy to testing. Then you can have your IAM users to assume a role depending on the workload. So for example, if a user wants to make changes to the testing environment, that user can assume the IAM role too in order to do that. So let's go back to our previous example. Say we have an IAM user and you want to allow the IAM user to assume a role. What should we do? First, we need to create a role. And second, we need to attach 2 policies to that role. The first policy is the trust policy. It defines the principles that you trust to assume that role. And here we allow user 1 to assume IAM role 2. The second policy is permission policy, something that we are already familiar with. It defines what actions this role can perform. So here we allow the role to read and write objects to a S3 bucket. And once we have the 2 policy in place, user 1 can assume IAM role 2. And with that role assumption, it comes with the ability to write objects to the S3 bucket. So everything we talk about so far, it's what goes on within a single AWS account. And depending on the size of your organization, you may have multiple accounts reading and writing data across buckets, across accounts. And this becomes very common when you're building data lakes in S3. So in this case, our best practice is to focus on bucket policy to grant permissions. And we are going to show you how you would do that. Here in this example, suppose we have two AWS accounts, account 1 and account 4. Account 4 owns the data, and account 1 needs to access the data. For account 1, we already know how to do that. We have an IAM policy that allows account 1 to read data from account 4's bucket. And now what will happen here? Even though account 1 wants to access the data, it shouldn't be allowed until the owner of the data, account 4, acknowledges that. Account 4 needs to say something about account 1 having that access. This is where bucket policy comes into play. A bucket policy, it's very similar to IAM policy, except it defines permission for your bucket. And a bucket policy defines who can access my bucket and what actions can that user do. The structure is very similar to IAM policy, but it requires an extra principal statement that says who the policy covers. And here in this example, the bucket policy allows account 1 to read and write objects to my bucket. Let's get back to our cross-account example. In order to allow account 1 to access the data in account 4 would need to have a bucket policy that grants permission to account 1. So now the setup is account 1 having an IAM policy, allowing the action, and account 4 having a bucket policy granting permission to account 1. And with the two policies in place, the sharing of the data is allowed. At AWS, we love scale. So right now, let's scale that up to make bucket policy even more powerful. With bucket policy, we have a way to exclude traffic that we don't expect. When we do that, we create a security parameter. In a bucket policy, we can add condition statements. Here in this example, we add a condition that gives account 1 access only to objects in my bucket with the tag reinvent. Account 1 cannot access to any other objects in my bucket. So let's say you have a bucket that is serving as a data store for your organization. You have different AWS accounts in your own org, and also other AWS services like AWS Lambda are reading data from your bucket. You know that this is true, and you want to enforce this logic as a parameter. How do you do that? A good way to define that parameter is by using the deny action with condition statements. Don't worry, we are going to read through this bucket policy step by step. So looking at this bucket policy, we are denying all S3 actions across all principals, essentially everyone, if certain conditions are satisfied. The first condition statement says we deny all access if someone is not from my organization. The second condition statement says we deny all access if the caller is not an AWS service. So then by combining the two condition statements, we deny access if the caller is not from our organization and if the caller is not an AWS service. This is how we write a bucket policy to define a parameter. And after this deny statement, we can have other allow statements to grant permissions to IAM users in my organization. Let's take a look at a second example. In a typical enterprise environment, we have some virtual VPCs, virtual private clouds. We're running all kinds of workloads, so we need access to the data. We also have people in our own data center. And we want to deny traffic except for callers from our VPC and data centers. How do we do that? Here again, we have a bucket policy. And we are going to use that strategy of denying access to everybody when certain conditions are met. We would deny access if call comes from outside my VPC. We would deny when call comes from outside my own on-premise networks. We would deny when caller isn't an AWS service. And we deny access when call isn't being made on my behalf by AWS. And so when all these conditions are met, we deny access. So the two examples we went through only use certain condition keys, and we have many more condition keys that you can work with. For detailed descriptions, you can go to the AWS documentation page and search for Amazon S3 condition keys or AWS global condition keys. So when you have a bucket with multiple user groups that you want to grant different levels of permissions, you probably have a very big, very extensive bucket policy with different statements. But instead of doing that, you can use S3 access points. You can set up one access point per user group. Access points are very useful to simplify access management for shared buckets. You can think about access point as dividing your bucket into multiple namespaces. For each access point, you can define an access point policy, which is something similar to a bucket policy. And with access point policy, you can do all kinds of access control, including limiting the traffic to specific VPCs or limiting traffic to specific S3 prefix. Now that brings us to our best practice number 4, and I'm really excited to talk about it because it's a new feature that we launched last year. We think about this as a big simplifier. In S3, there are multiple ways to grant access to your data, and we just talked about it, and you can use IAM policy and bucket policy. And the third way to do that is through access control lists, or what I call ACL. ACL predates IAM, and it's the original way S3 grants access to your bucket and object. It's an atomic attribute for each bucket and each object, and you have to invoke it individually. So let's look at this example. This is the ACL for an object that I created in my bucket. It shows that I am the object owner. I have the permission to read the object, and I also have the permission to update the ACL. Now when an external account writes an object to my bucket, the ACL tells a different story. It shows the object it's owned by that external account. And because the object writer gave me permission through ACL, I now have the permission to read the object. The important point here is that the object writer needs to give me, the bucket owner, permission. So with that knowledge, let's see how cross-account write is done today when ACLs are enabled for your bucket. Here you have a bucket. An external account writes data to your bucket. There are 3 areas to pay attention to. First, for the write, the object writer needs to give you, the bucket owner, permission through ACL. Second, the objects are owned by the object writer. Third, because bucket policy only applies to objects that you own. And therefore, you cannot use bucket policy to grant permissions on those objects to other accounts. For example, accounts C, D, and E. You have to do that through ACL. So we recommend customers to use bucket policies because one single bucket policy, it's simpler to review and update. It's far better than managing individual echoes, particularly at scale when you have hundreds, thousands, and even millions of objects in your bucket. And with this in mind, we launched a new feature last year to give you the ability to disable echoes for your bucket and all objects in that bucket. Once you disable echoes, the echoes can no longer be used. The bucket owner becomes the owner for all objects in that bucket. And therefore, all permissions are therefore governed by your bucket policy. Many customers tell us that it's great now they have the option to disable echoes, but they don't know which applications depend on them. They want more visibility about their echo usage. So we heard the feedback, and right before reInvent this year, we launched a new field in Amazon S3 Server Access Log and AWS CloudTrail Log to capture your echo usage. The new field indicates whether or not your requests rely on echo for authorization. It's useful when you have to identify permissions that use echoes, then move those permissions to your bucket policy, and then disable echoes completely for your bucket. The last best practice we will talk about today is to review your permissions with IAM Access Analyzer and to log your requests with Amazon S3 Server Access Log or AWS CloudTrail Logs. When you have many buckets in your account, you want a quick way to review your existing permissions. For this, we have a tool called Access Analyzer for S3. This feature analyzes permissions for your buckets and provides a simple dashboard that shows your buckets that you share publicly, as well as buckets that you share with external accounts. Let's take a look at an example. Here in this example, you can select Access Analyzer for S3 on the left panel. Next, you choose your region. And once you do that, you will see a list of findings. So Access Analyzer reviews your bucket policy, your bucket echo, access point, and block public access settings to produce findings. It will list buckets that have public access at the top panel and buckets that you share with external accounts at the bottom panel. So here in this example, you see that I have 4 buckets that I share publicly, as well as 2 buckets that I share with other AWS accounts. The dashboard also tells us the means by which I grant the permission. For example, here, through bucket echo and bucket policy, so that we can pinpoint those mechanisms and go back and make the necessary adjustments. The ability to audit who access your data is very important. To keep a detailed record of all API calls made to your bucket, you can turn on Amazon S3 Server Access Logs or AWS CloudTrail Log. It's useful in compliance. It's useful in security audits. And with the log files, you can do query, you can do analysis on the data to have an understanding about your access patterns. Amazon S3 Server Access Logs gives you a lot of details about your requests. Some information include basic information like the requester, the operation, key name, as well as detailed information like the user agent, object size, TLS version. For all the details, you can go visit our documentation page. So we went through 5 best practices today. Let's do a quick summary. Best practice number 1, enable block public access at the account level that helps you prevent unintended public access. Best practice number 2, enable default encryption and to use bucket keys to reduce your cost for KMS encrypted objects. Best practice number 3, use bucket policies to grant permission to your bucket. You can also use deny statements to enforce a security parameter. Best practice number 4, disable echoes for your bucket. By doing that, you own all your objects in your bucket and all the permissions are defined by your bucket policy. Best practice number 5, use Access Analyzer for S3 to quickly review your permissions. Log your request with Amazon S3 Server Access Log or AWS CloudTrail Log. If you're looking to increase your knowledge on AWS storage, we have created a lot of wonderful materials. Go to aws.training/storage to learn more. And with that, thank you so much for attending. We'll be around to answer any of your questions here in the room.